Hello and welcome back to my test-driven development series, and in today's video we're going to be looking at Roman numeral kata for driving algorithms out from the tests, basically. It's a really simple kata. You basically got the constraint of 1 to 3999, so 4,000's not a number we're going to contend with. Of course, we've got I, V, X, L, C, D, and M, all for our various numbers, or Roman numbers, rather. Anything else should really throw an exception, because it's an invalid case. Of course, we're going to have an interface, and it's going to... We're only going to worry ourselves about the decimal to Roman numeral converter. So we're going to basically take a numeral in and convert to a Roman numeral character. So here we've got some examples. We've got I for 1 and VI for 6, XVI for 106, MCMXCIV for 1994, and MMMCMXCIX for 3999, or bound. Obviously going the two different directions, but we're only going to focus, as I said, on the one direction. Did I just say one direction in a video? Never mind. It was bound to happen at some point. I say plenty enough words, don't I? So with that, let's get started. Okay, so I've done a little bit of ahead of time work as usual. I have this skeleton of a class of the decimal to Roman numeral converter. So it's just convert to Roman numeral, takes the numeral in, and it's going to return our different Roman numerals. We have the interface, of course, from before, and I have a very basic test that I have written out here, not wrote out here, written out here. So I would say let's get started. I think the first thing I would want is a nice little theory in here. Let me just type fact, and then I can change that to theory. And what we probably want to do to start with is check invalid values throw an out of arguments exception. Now this is the sad path way of testing. In other words, you start with the exception cases and then work into the accepted cases. It's quite an interesting way of programming. So let's just start with that. So this is all out of range. Now you may remember in our requirements we had 1 to 3999. So these are both out of the range. So we're going to should throw an exception if out of range. And again, I like to define what I would call to have this happen. So I'm going to go assert throws. In the exception case, it's a little bit different. We just basically define it like this. So I'll just kind of follow along, guys. We're throwing, and it's a generic. The throws is generic, and we pass the type we expect, and then we do a lambda expression, and then the thing that we're going to call. So we would then define what we're going to call up here. Well, at least the type that we're going to use to make the call with. So something like that. And just do a little bit of formatting, a little bit of house tidying, why not? And pop the method in here that we expect with out of range in the argument, and pop that down like so, and get rid of the when, given and when steps because we're not using them. All right, cool. Let's go up to the tests here and run the tests. Let's see what we get. Well, we get 2 failed tests, and we get 2 failed tests because we are getting the wrong type of exception being thrown. We are getting a not implemented exception rather than an argument out of range exception. So we need to handle this, and we can do this with a method. So let's leave this as its full file and just pop in this numeral into this private method I'm going to define down here. Check valid range uint numeral. And what this is going to do is it's going to have 2 arguments, basically, is less than minimum range. So this is one condition in which it will fail, and the other is greater than maximum range, which will look like that. Okay, that's our 2 arguments. The reason you should define a bool like that, it makes it a little bit more readable. Simply, that is all you need to know. So now I can just simply put. So I've defined the condition as to when we would throw this exception. We can provide a string for our out of range exception message if you wanted to, and we can go something like decimal number must be between 1 and 3999. Let's use it. So throw new argument out of range exception, name of numeral, and the message that we want to display. And with that, we just need to implement this little thing. This is a good little check to ensure all is well. We can just return null otherwise. Run the test, and it passes. So we went from 2 failing to 2 passing tests. Good place, in my view, to commit. Let's go. Let's create the next test, shall we? Okay, no point wasting time. Let's get straight into making it a theory, and let's call it what it's gonna do, which is convert to Roman numeral, right? Decimal to Roman numeral. We can pass in the numeral and an expected Roman numeral. And what we can do is generate some inline data. And we can start with 1, which is our first valid number, and what we expect it to return, which would be I, right? Our when step can contain what we are going to do. And remember, folks, like I've done this many a time at this point, but you know, define the method, you know what's going in it. If you're unsure, in this case, it's not too hard for me to remember, so I just did it. And it's going to return a numeral out, which will be a string. I'm not a particular fan of var. I prefer defining things, so it's more clear to the person reading it, and they don't require that IDE in order to understand what I've written. So expected Roman numeral compares to Roman numeral. That is a valid test in my books. Let's test .net even test, and let's see what we get. Well, of course, we get null instead of I. So let's go into decimal to Roman numeral and start to implement something simple. This is the fake return, which is not very dynamic. So we can, obviously, it's statically written at the moment, right? Next, we can define a bit more behavior. So 2, 3, all these are the same vibe, right? 2, 3. I think that's about all we can do. But it gives us three points to consider. So we're going to have 2 failing tests, 1 passing test, as we would expect, and that's what we get. So that's fine. And we can make some sort of implementation now. So we could do 4, a very basic for loop. And basically for every numeral, we define this numeral up here. Roman numeral equals string.empty. Ideally, a better way of writing an empty string instead of just like this, because it's much clearer to the in a way the end user, the next developer that's going to be reading this code, that's the intention, as opposed to an accident. And for every Roman numeral, we can just add I and then return Roman numeral. That seems like a reasonable iteration to me to getting towards the goal of having a converter. So we can add that, commit that. The next step, we can challenge ourselves, which first challenge would be 4. Another challenge would be 5, but it's a different vibe. Right, the test is a different vibe. We don't need to worry about that right now. We'll just go with 4 only. Let's run the test. See what we get. Well, we get 1 failing test, and who would have thought that, right? Next thing we could do. Now we're getting into potentially tricky-ish waters, so I'm going to commit and try a thing, and if I fail, I can always go back to that. What we can do, we could put an if condition in. So if numeral equals 4, then we could bypass the lot and return IV. This is, again, it's very statically written. It's not an algorithm yet. Same vibe for 5, same vibe for 10. You know, you get the idea. We don't need to waste time here. We know this is going to be the thing, right? So we can just comment this implementation out, add this test, add the next test, run the tests, C2 fail, implement our code, C2 pass. Done. Right. This leads us to the point where we are getting a pattern. Okay. And from this point forwards, we now need to implement something that will deal with this. right? In other words, this is the point where I'm going to refactor some sort of pattern I'm seeing into something better, right? So that we can end up with something quite, algorithmy from, we've triangulated, and now we're going to try and check that our triangulated test still works if we drive in some sort of algorithm. So let's do something to that effect. Let's create a dictionary. Because a dictionary stores a unique key to a value. And the value does not have to be unique, but the key does. So we can do something to this effect. And I'm just going to define it like so, and then we can create the brackets in here, and we can do something like that. Let's not go too crazy. Let's start with what we've done. So let's do 1 to I. Let's then define 4. Whoops. I ought to just leave caps lock on at this point. And then we can define 5. And then we can define 6. Yeah, we'll just define 5 like this. I don't think we need 6. We'll have to see how it goes. So 1, 4, 5, right? That's where we're up to. We've got 4, 5, 6 like this, right? These are our interesting cases. This is our, default case. So you can kind of see the dictionary is going to start at the top, work its way down until we're at the bottom of it. Do you guys leave a trailing comma? That's an interesting one, isn't it? I don't know if it's worth warranting a long discussion, but such as. So we can... very angry .NET test. See, everything still passes, right? But we've got some code we're not really using now in this numeral to Roman numeral dictionary that we've defined up at the top here. So let's see, what can we do? We could do a for each loop. And we can do something to that effect. And we could do a while loop. There's nothing wrong with doing a while loop as long as it doesn't run on forever. And so long as the numeral is greater or equal to the item.key. Sounds good to me. Roman numeral plus equals item.value. And numeral, on the other hand, we'll need to actually reduce the numeral by the key each time. Now remember, the key was this number. So what we're saying is, as you loop round, add the value of the Roman numeral. So like if you say have like 5, you come in here, you add 5 or IV, so that the V even. For 5, right? You add this V to the Roman numeral, then take 5 away, and what you're left with is 0, and therefore you're done, right? Because numeral is no longer greater than any key, basically, any key. So if we get rid of this implementation down here with a comment, just in case we've screwed it up, we can do .NET test. See, it still passes. And then we can remove this implementation here. This is basically the refactor step, but taken to its extreme logical conclusion. So from this point, we can run the tests again to check that it all still works. Commit. And then in our Roman numeral test, we can add the rest. So we can do 9 is the next case, I would say, which is IX. 10 is X. Not to be confused with the replacement for Twitter. 40 is XL. 50 is L on its own, like that. 90 is XC. 100 is just C on its own. How many did I say I was doing up to? Blimey. Right, let's keep going. CD is 400. 500 is D on its own. 900 is CM. 1000 is M. Not 100, 1000 is M. And then we can do some acceptance tests down here. 1994 is MC, MX. Sorry, MCM Civ, that's it. X Civ, like this, right? MCM X Civ. And 3999, this is the bound, is MMMC MXCIX, like this, I think. MMMCMXCIX, yeah. So what I'm going to do now is run the tests. There'll be a lot of failing tests, an awful lot of failing tests here, 12 failing tests. But remember, now all of this is the same vibe because we have, for our tests, right? Because we have this pattern established, which is this thing here. So let's implement the remainder of this and watch how miraculously all of these tests start to pass. So if we take 9, IX, go to 11 failing tests, there we go. We can do 10, and we'll have 10 failing tests, which is ironic. Matches, right? And then we can do 40, and that would be how we defined it with XL, and we'll have 9 failing tests. And you don't have to do it this, when you've got a level of confidence like this, just do the rest, right? You don't need to be so dogmatic and robotic. We can be a bit more human, one would say, and just define out what we need, what we think is going to work, and then if it doesn't work, just take our ideas back to the drawing board. And that might happen, depends on the algorithm. Remember that each test you add is a new challenge to the code, and it might be that one of those challenges it in such a way that you didn't foresee, and you'd have to work it out. But you can comment the up to the point it passes and the tests, and then just work out the remaining ones as you go, right, with new implementation. So let's see if all of that passed. And there you go. So that concludes more or less how to drive algorithms out from the tests. The idea being, you start with the exception case, you define the simplest thing, some minor challenge to it, a different challenge, a different challenge, a different challenge, and a different challenge, right? Or this challenge here. And you start with the if conditions, and you then, when you've got that triangulation, you can then take that statically static code that only returns in certain conditions, very conditional, very static kind of code, into something a bit more dynamic and an actual algorithm that does the same thing. As long as you've got enough test data, all should be well with the world, and that is pretty much how to do it, folks. So with that, have a good day, and yeah, hope to see you in the next video.